Isa ka rin ba sa mga estudyanteng nagiging weakness ang strength of materials? Nasa-stress ka rin ba sa mga topic about stresses? Don't worry, ito ang video na para sa iyo. And if you want to learn more about this topic, please keep on watching. So first, let's define muna ano yung stresses. Yung stresses is the internal resistance force per unit area acting on a material or intensity of force distributed over a given section is called stress. In simple terms, stress is equals to force over area. So, merong iba't ibang uri ng stresses. At sa video na ito, bibigyan muna natin ng focus yung dalawang stresses na na-encounter natin sa strength of materials. Yan yung normal stresses at shear stresses. Ano nga ba yung pinagkaiba ng normal at shear stresses? Pareho lang silang stresses, which is yung formula is force over area. Pero yung pinagkaiba is yung area. Yung pag-determine natin ng area kung saan nag-a-act yung force. So sa normal stress, lagi nating tatatandaan na pag normal stress is always yung force perpendicular sa cross-sectional area ng ating material or body. Yung shear stress naman is always parallel sa ating cross-sectional area. Ibig sabihin, pag ito yung body at may internal force or may external force na mag-act dito, yung normal stress na madidevelop is itong force na ito, which is perpendicular sa cross-sectional area ng material na ito. Yung shear stress naman is that parallel sa cross-sectional area ng body na ito. First, let's discuss muna yung normal stresses. Yung normal force again is always perpendicular sa ating cross-sectional area. Yung normal force is either tensile stress or compressive stress. Let's say, meron tayong dito object. Meron tayong dito external force P. Yung formula, pag ganito, yung orientation, ito ay tensile stress. Yung formula is always, again, stress is equals to force over area. Ito yung force, ito yung area, which is perpendicular sa ating force. Kung compressive naman, the force tends to compress our material. Again, force over area. Yung area is always perpendicular yung cross-sectional area sa ating force. Let's say we have this example. The bar ABCD shown consists of 3 cylindrical steel segments with different lengths and cross-sectional areas. Axial loads are applied as shown. Calculate the normal stress in each segment. So, first, ano yung hinahanap? Yung hinahanap is the normal stress in each segment at may applied na axial loads. Ano? Pag sinabi nating axial loads, yung axial loads or yung force is along the axis of our material or body. Again, ano yung nahanap? Normal stress in each segment given na yung mga forces at yung various areas ng ating segment. Sa segment AB, yung cross-sectional area niya is 36 mm squared. Sa segment BC, yung cross-sectional area niya is 54 mm squared. At sa segment CD, ay yung cross-sectional area is 48 mm squared. So first, yung unang gagawin natin is hahatiin natin ito into segments. Let's say this is segment AA. Ito, segment BB. At sa last, gagamitin na lang natin yung part na ito para mas madali. Segment CC. At segment AA, yung free body diagram natin dito is magiging ganito. 800 newtons. Yung cross-sectional area nito is 36 mm squared. Yung cross-sectional area niya. So, meron tayong dito lalabas na normal force P. Again, pag hinati natin ito, may maglalabas dito na normal force P. So, summation f of x equals 0, let's say assuming to the right, positive. So, P minus 800 equals 0. P is equals to 800 newtons. Therefore, yung stress at segment AA, stress or segment AB is force over area, wherein yung force natin ay 800 newtons over yung cross-sectional area na 36 mm squared is equals to 22.22 Newton per mm squared or 22.22 MPa, megapascal. Next, at segment or cross-section BB for segment BC, yung free body diagram natin is lahat ng nasa loob ng ating cross-section or segment. So, mula dito, papunta dito. Magiging meron tayo 800 newtons, 1,800 newtons, at may lalabas na normal force dito. Let's say P. So first step again, summation or f of x equals 0, assuming to the right, positive. So P plus 1,800 minus 800 equals 0. P is equals to negative 1,000 newtons. Or ibig sabihin na yung direction ng ating P is towards our cross-sectional area. Therefore, stress at segment BC is equals to the force over area. Yung force is negative 1,000 newtons over the area which is yung cross-sectional area ng material na ito is 54 mm squared or equals to negative 18.52 Newton per mm squared or m megapascal. Ibig sabihin ng negative is that compressive yung direction ng force natin. Pwede natin sabihin 18.52 MPa compression. So, sa last segment or at cross-section CC. So, yung Fibroidy diagram nito is lahat ng dito papunta dyan. Therefore, magiging meron lalabas dito na internal force P. First step is summation of f of x equals 0, assuming to the right positive. So, negative P minus 1,400 equals 0. Therefore, P is equals to negative 1,400 newtons. So, ibig sabihin ng negative nito, yung assumption natin is opposite sa correct na behavior. Ibig sabihin, yung P natin is compression. Therefore, the stress CD, segment CD is negative 1,400 newtons over yung cross-sectional area ng body na ito is 48 mm squared or equals to 29.17 MPa or 29.17 MPa compression. Next example. The 80 kg lamp is supported by two rods AB and BC as shown. If AB has a diameter of 10 mm and BC has a diameter of 8 mm, determine the average normal stress in each rod. So, first step, identify muna natin yung given. As always, dapat alam natin kung ano yung mga given. So, given, meron tayo yung rod AB is 10 mm diameter. Yung BC is 8 mm diameter. Meron din tayong given na weight which is 80 kilograms. Ano yung required? Yung pinapahanap? Yung required is yung stress, normal stress, or average normal stress in each rod, or simply the stress in each rod. So, stress in rod AB and stress in rod BC. So, ano yung free body diagram? Mas madali if ipa-follow mo yung format na ito sa pag-solve or pag-analyze ng mga stress problems. I-identify mo yung given, identify mo kung ano yung hinahanap or required. Then, pag mag-start ka ng solution, first start with a free body diagram. So, given sa ating problem, pwede nating sabihin na ito yung free body diagram natin. Say, tension BC and tension BA. At meron tayong 80 kilograms na lamp. And this is oriented 60 degrees. This is has a slope of 4, 3, 5. So first, yung strategy dito, pag nag-solve tayo ng mga stress problems, pag sa solution, yung unang-una is first, determine the forces. If hinahanap yung mga stress, determine the forces. Kasi di ba yung ating formula for stress is always force over the area. So first, let's determine the forces or internal forces ng ating rod. So paano natin ma-determine yung mga forces? Meron tayong equilibrium equations. So ano nga ba yung mga equilibrium equations natin? Meron tayong summation f of x, summation f of y, and summation of moments equals to 0. So in this case, pwede natin gamitan ng summation of f of x and summation of f of y. So, para sa ating summation, f of x equals 0, assuming to the right positive. So, kukunin natin yung mga x components ng ating free body diagram. So, for TBC, ano yung x component niya? Again, yung x component ng ating tension BC is 4/5 TBC. Bakit naging 4/5? Again, sa statics natin, pag kinukuha natin yung x component o yung pag nire-resolve natin into components ng isang force na may angle or slope, sa case na ito, given yung slope, kung ano yung parallel sa axis na kinukuha natin, yun yung gagamitin natin distance over the hypotenuse. So since x component yung hinahanap natin, which is hinahanap natin yung parallel sa x-axis. Ano yung parallel sa x-axis? Yung 4. So 4 over the hypotenuse 5 times the magnitude of tension BC. Okay? Next is minus the x component of our tension BA. Ano yung tension? Ano yung x component ng ating tension BA? Simply, TBA cosine 60 equals 0. Meron tayong dalawang unknown. Therefore, pag may 2 unknowns, kailangan natin ng 2 equations. So, isang equation pa lang meron tayo. Pero, meron pa tayo tatlong equilibrium or dalawang equilibrium equations, which is summation of f of y and summation of moment. So, in this case, pwede natin gamitin yung summation of f of y equals 0, assuming upward positive. So, again, kukunin naman ulit natin lahat yung y components ng ating forces. So, for TBC, ano yung y component niya? Again, pag may slope, kukunin mo yung parallel sa axis over the hypotenuse times the magnitude of that force. So, for y component ng tension BC is, ano yung parallel sa y-axis? 3. Therefore, 3 over the hypotenuse 5 times the magnitude or tension BC. Next, for tension BA plus T tension BA sine 60. Ano pa yung y components natin or mga y forces natin? Yung 80 kilograms. Pero pwede natin itong i-convert into newtons, multiply natin ng acceleration due to gravity na 9.81 meter per second squared equals 784.8 newtons. So, pwede natin i-divide ito minus 784.8 newtons equals 0. So, meron na tayong ikalawang equation. So, pwede na natin masolve si TBC at TBA using our calculators or using the equation mode using two unknowns to equations sa ating calculator. So, solving simultaneously, makukuha natin na si tension BC is 395.24 newtons at si tension AB ay or tension AB or BA ay 632.38 newtons. So, na-determine na natin yung mga internal forces or yung mga tension in each rod. So, pwede na natin makalculate yung stresses in each rod. For stress at AB, again, it's the force over the area. Ano nga yung force sa AB? Yung tension na may magnitude na 632.38 newtons. Ano yung cross-sectional area ng rod AB? Given, meron tayong diameter ng rod AB na 10 mm diameter. So, therefore, area of a circle. So, pwede nating sabihin na area of circle is pi d squared or pi times 10 squared over 4. Pag given yung diameter, pwede na nating gamitin yung formula for area of a circle na pi d squared over 4 or pi r squared. So, kukunin mo lang yung radius na ito, which is 5. So, in my case, yung ginagamit ko is pi d squared over 4 o yung diameter na agad. So, therefore, pi times 10 squared over 4. Therefore, the stress at AB or rod AB is, solving this in your calculator, makakakuha tayo ng 8.05 megapascal. So for stress, solving for stress, BC, again, force over area. Ano yung force? Yung tension na 632.38 newtons over yung area ng rod BC. So given that the diameter of rod BC is 8 mm over pi 8 squared over 4. Therefore, the stress at BC is 7.86 megapascal. So, ganun lang kasimple yung pagsasolve natin ng mga normal stresses. Again, ano dapat nating tatataan sa pagsasolve ng mga normal stresses or yung kahit ng iba't ibang type ng stresses? Again, for normal stresses, first, again, ano nga yung formula for stress? Yung stress is always force over area. Whether it is normal stress, shear stress, bearing stress, or kahit anong pang stress niyan, it's always the force over area. So again, gamit ng formula na ito, yung una-una nating pag magkaka-encounter tayo ng mga stress problems, yung una-una is identify muna natin yung mga given. First, identify given. Next is, ano yung pinapahanap? Identify required. Whether it is normal stress, shear stress, bearing stress. So, ano yung pinapahanap? Next is, it is helpful sa ating pagsasolve kapag meron tayong free body diagram. Kasi, dito tayo magbe-base ng mga assumption ng mga forces natin at para pagsasolve natin or pagpa-determine natin ng mga forces. Next is, since yung formula for stress is force over area, so dapat ma-determine natin kung ano yung gagamitin na force at ano yung gagamitin na area. So, using our FBD, masasolve natin yung gagamitin natin na force. So, sa pagsasolve ng mga gagamiting force, pwede natin gamitin yung mga equilibrium equations, which is summation of f of x equals 0, summation of f of y equals 0, and summation of moments equals 0. Next, 5. Solve for what is required. Ito yung usually na flow pag nag-deal tayo ng mga stresses problems. Identify natin yung given, ano yung required, magdodrawing tayo ng free body diagram for bases or equations. Next is equilibrium. Using equilibrium equations, masasolve natin yung mga dapat nating gamitin para sa ating stress equations. At kapag na-identify na natin lahat, yung mga force, yung mga area, madali na natin masasolve yung stresses. So, I hope natutunan ka sa video na ito. And for our next video, i-discuss natin yung shearing at bearing stresses. So, thank you for watching.